Alright, so we're going to be talking about particle motion today. So to get us started, I'll get some numbers up there on the screen. Alright, let's take a look at what kind of numbers we're getting. So here we have the distance, total distance carry including rollout. We have the launch, and this is the angle that the club is making with respect to the ground right before impact. Then we have the club speed. This is how fast the club is going right before impact. We have carry. That's how far the ball carried in the air. And then down here, we have ball speed. Ball speed is going to be how fast the ball is going right after impact. We have now, what I want to take a look at here is focus on these two numbers, the ball speed and launch angle, because we're going to be able to calculate how far the ball travels, how long it takes, what's the max height it reaches, and at what time using particle motion. We don't necessarily have to have a simulator to find all of those numbers. A golf ball, it has the flight kind of like this. We know that as the ball is traveling upwards, it's going to be decreasing in speed because our velocity is positive, but our acceleration, gravity, is negative. It's pushing down, so decreasing in speed. For a brief moment, it will pause. Brief moment, just kind of like throwing up a golf ball. It's going to pause for one brief moment and then come back down. And when it comes back down, it's going to be increasing in speed because both the velocity and the acceleration is negative. Now I'll take you over to the classroom. So I said earlier that we'll be able to make some calculations based off of our launch angle and our ball speed. Now I did learn this the hard way, getting some inaccurate numbers. The ball speed is in miles per hour, but we need it to be in meters per second. So 96.6 miles per hour is equal to 43.18 meters per second. Got that? So now we're gonna go through our equations here. So we can represent these as x components and y components. So the x is going to be representing the horizontal movement, and then the y is the vertical movement. So no acceleration horizontally, but vertically, of course, we have gravity, which is negative 9.8 meters per second, and that is a constant. Now we just take the antiderivative of that to get velocity. So from there we have these guys, and then we have position. So, and again, so you take the antiderivative of that to get position. So one thing to be aware of is that right here and right here, that's going to be our plus c value. But in this instance, we know that our plus c value is going to be 0 because we're starting on the ground. So no need to worry about those guys, the whole calculations. We don't have all of our numbers though, so do a little trick and we find that the initial velocity can be represented this way, and all we have to do is substitute these little equations in for the initial velocity, and we get these equations. So we can use these, and these will easily be calculated with only these two values. So now, I did some calculations here to find my maximum height. So to find my maximum height, we talked about this earlier, it's like throwing up a pin. It's like throwing up a pin, it's throwing up a golf ball, it's gonna stop momentarily at the top. So that's when the velocity is going to equal 0. So we set our velocity equal to 0, and we get that at time equals 1.405 seconds. That is when it is at rest for a brief moment in time. And we plug that in to our position equation. Again, these are both the y, so it's going to be for vertical movement. And we get 10.574 meters. So that is our maximum height. Maximum height is right here. Now, this is where we're going to really check ourselves to find the total distance, because on the simulator, we have our total distance had a total carry of 124.6 yards. So we go to our position equation and we set that equal to 0 because that is going to be when the ball is on the ground, when it has just hit the ground. So position is equal to 0. And we get that it hits the ground at 2.811 seconds. And from there we can plug it into this equation or use this equation because we have those two values, and we get 125.77 yards. And that is pretty darn close to right here. So I think our calculations were accurate. So hopefully now you know how to use particle motion and tie it back into golf. Thank you.